Now, at the beginning of this chapter, we're going to begin talking about some of the derivative rules, some of the shortcuts we can use in taking a derivative. So derivative rule number one is, suppose we have a function that just equals a constant. And of course, what we know, what would happen if we graph this, it would be a horizontal line. And a horizontal line, of course, has a slope of 0. And so that's really the logic behind the rule that if we take a derivative of a constant, what we get is 0. So that's rule number one, sometimes called the constant rule. Rule number two is, suppose what we have is y equals the product of a constant times a function, and we want the derivative of the constant times the function. Well, of course, the derivative is just a limit, and a limit is a very linear thing. We can easily factor something out from any limit, so we can factor it out from the derivative. And so what we're left with is that the derivative of k times f of x is just k, the factor, factored out in front, times the derivative of f of x. And this is called the constant multiple rule. It's a very useful rule. Now suppose what we have is a sum of two functions, f of x plus g of x. Well, we take a derivative of a sum, derivative of f of x plus g of x. Of course, a limit is also something where a limit of a sum is the sum of a limit. And so very easily, we can just separate this into derivative of f of x plus the derivative of g of x. And much in the same way, if we're subtracting the two functions, f of x minus g of x, the derivative of the difference of the two functions, derivative of f of x minus g of x, is just going to be the difference of the derivatives. Derivative of f of x minus the derivative of g of x. And so notice, for example, one thing this means immediately is if we take the derivative of any function plus a constant, well, what that would mean is the derivative of the function plus the derivative of a constant, which is 0, which is just the derivative of the function itself. And so in other words, we could add any number to a function, and then when we take the derivative, it doesn't change. That's an interesting little fact. So right now, notice that what we have here is that the derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. You might be tempted to think that products and quotients are just as simple, but they're not. And we'll deal with those slightly more complicated rules in future videos.